Hello and welcome back to another episode of From the Field. I hope everyone enjoyed the previous show from Howdy Partner. I know I always do. And I am in the office today in Wellington, New Zealand. I'm actually decided to have a slightly different background this time because normally when I'm streaming in the office, I am in the same booth, but I'm over there and you get the creepy Pecky looking at you, which I decided that having a giant pig in the background wasn't good. So today we have with us Sam. I'm not even going to try to pronounce your last name because I'm probably going to butcher
It's the easy one, right?
it. So I'll get you to introduce yourself to the audience and also to answer two of my icebreaker questions I ask every guest. The first one is, what was the first programming language that you learnt? And the other one is, what was the first major project you worked on? And I know that this is probably going back a few years, but if you can, we'll see how good your memory is.
Absolutely, Casey. Hey, that's fantastic. First, your office looks cool. That's awesome. Yeah. Uh, and second, thank you for having me on your show again. I really appreciate this opportunity to be on your show again. So it's absolutely an honor. And thank you for featuring this topic. I'm really glad to bring it to our audience. My name is Sam Kominori from the field. I'm a senior solutions architect with AWS. My role entails working with AWS enterprise customers to understand their business and technology goals, and then to help AWS technology be an enabler for these goals. It's an interesting, you asked those two ice-breaking questions. The first programming language and my first project. Yeah. So at the risk of showing my age, I will. My first programming language was an IBM AS400 CL. That's a command language, and there's a language called RPGLE. That is a report programming generation language. I remember very well because I had been a corporate trainer as well on IBM AS400, and I was an administrator too. Project, again, I'm really showing my age here. The first project was Y2K for Apple Corporation. That was the year 2000 project, So yeah, that's me. So I got a couple of decades of experience in the IT industry overall, and yeah, that's me, Casey.
Even as a boy, I actually would have nearly been a teenager, I think, when the Y2K was all the rage. I remember that being a huge thing, dominating like the
Yeah,
news cycles. People were saying it's the end of the world because everything's going to stop working, and all of that jazz. Which is, yeah, that definitely takes it back. If anyone in the that's watching like has any memories of Y2K, definitely share them as well because it's definitely one of those standout times. I actually still remember having the Millennium edition of Windows. Windows
ah,
ME what came out on that time. It was like special edition. It was absolutely terrible as an OS, but it came with a fancy sparkly disc.
sure,
I
sure. Yeah.
guess now I should ask you, Sam. What are we going to be covering today?
Yeah. Today, the topic really is AWS local zone for telco. In other words, AWS local zones, meaning what exactly are these AWS local zones? Why do we need AWS local zones? And what are the use cases? I'll broadly touch on the generic use cases for local zone, and then I'd be very keen to bring some context of a telco use cases, right? And maybe I'll take some examples. Recently, we have launched a local zone in Auckland, New Zealand. So yeah, I'm based in New Zealand, Auckland, New Zealand. For the sake of our audience, I forgot to mention earlier. So yeah, and then if time permits, I'll be keen to talk through some of the customer references as well in real world examples and architecture point of view. How does it work? and I'll show high-level architecture components in terms of what are the region construct and what are the local zone construct, and what are the synergies between these two, and how they can be integrated. Right?
First of
That's
all,
yeah,
yep.
yeah,
First of all, I won't hold being in Auckland against you. And the other one is also like for everyone watching, like I don't have a telco background, so I'm going to be standing in as yourself, but feel free to ask questions. But my one is going to be a lot of time is I have no idea what that means. Please explain. So it's going to be I'm going to make sure that we don't get stuck in that three-letter acronym hellscape that we quite often get stuck into. Cool. Sam, do you want to kick off your presentation, or do you want to just give a bit more of an overview?
yeah. I can kick off a presentation, but before that, speaking of acronyms, I must give a heads up that there will be some acronyms so in my presentation, but yeah, I'll I'll describe that, and as needed, we can dive a little bit deeper, if not to the nth degree or nitty gritties, but yeah, I'd be happy to delve deeper into that. Not expecting all of my audience or yourself be telco, expertise with all the acronyms. So yes, uh, apologies if you
It's all
come
good.
across
We hit
any
alert.
just an alert, right? So with that note, yeah, I'd like to kick off the presentation. Um,
I'll bring it up for you.
yeah,
There we
sure.
go.
Thank you very much. I appreciate that. So maybe I just want to kick off with why we need a local zone, because we have AWS as regions, and our regions deliver the cloud services for a large population area. So why do we need local zone? As I was mentioning earlier, we have recently launched a local zone in Auckland. So I'd like to take that as an example here and there, and yeah, mm, and touch on other examples as well, right? So first and foremost, in this context of launching Auckland local zone in Auckland, we have AWS Sydney region, yeah, which is one of the earlier regions by AWS, Sydney, Australia, indeed, right? So it contains 300 plus fully featured AWS services. Most of the use cases do fit them, such as SAP applications or back office applications, big data apps, and so forth, right? So because they are leveraging all those purpose-built as well as fully featured services in the region. So why do we need local zone then? So the feedback from our customers, not only in this region but globally, but I'm talking specifically about Auckland, New Zealand region in this context. Feedback from our customers, including our telco customers, they reveal a compelling need for low latency performance, particularly for workloads and applications dependent on existing on-premises systems, monolithic systems as well, and database connections and IoT workloads and other cloud-intensive tasks, right? So not only the customers from the business context, but even the developers, right? They also expressed a desire to run numerous applications in AWS cloud worldwide, closer to their end users. So these applications, as you could imagine, encompass latency sensitive and throughput sensitive workloads such as remote real-time gaming and machine learning inferences and hybrid migrations. So although the requirements may not directly apply to our telco customers, of, for example, uh, the gaming may not be directly applied to the telco customers, but the underlying principle, right, that remains relevant. So our customers and the developers, they have shared various challenges they encounter when addressing these workloads, right? So these include procurement and operations and maintenance of IT workloads, within their own data centers or co-location facilities, which is not optimal, right? Adding costs and complexity and operational overhead. So, does it resonate with your experience, Casey, in terms of running such low latency or latency sensitive applications within the customer premises?
See, I was actually gonna just made a mental of what you're saying is gaming and telcos, but
Yeah.
to that point, the rise of mobile gaming is quite apparent. So I think the telcos do have to take that into consideration. Obviously, they're not hosting that
Mhm.
infrastructure, but that is all happening over their 4G and 5G networks, and even 3G these days. All right, I think
Indeed,
that's not
indeed.
long for the world, right?
Yes, yes, indeed. And yeah, and yeah, sorry, go on.
And I find that in terms of for local zones and edge cases like that, it really comes down to particular industries and those niche use cases, especially in a country like the size of New Zealand, where I think that in the North American context and like America, where it's quite a big country in itself, um, the local zones come much more into their own.
Absolutely, I couldn't agree more. Those countries where the population is large and even geographically quite diverse, so the local zones become very compelling. So yeah, maybe I'll briefly touch on why do the customers want AWS to provide these services, right?
Hmm.
So if you take a step back, as part of our discovery, we learned that the issues organizations face when managing the workloads on their own data centers or on premises are IT challenges, right? And then there is a developer challenge, as I was mentioning earlier, and there are some business challenges as well, right? So when it's IT challenges, I mean the procurement and provisioning cycles are complex, right? Sometimes it could take up to 6 months to get servers deployed. I had that experience personally myself when I was relying on on-premises infrastructures and processes and so forth, the procurement processes. And there are multiple vendors to procure as well as and installations and maintenance, maintaining on-premises infrastructures and so forth. These challenges are they are common. Uh, many of that many of our customers they expressed these challenges to us when we engage with them. So, how can we bring efficiency and consolidation in procurement, installation, and maintenance? That's one of the areas we looked at. And then there is a significant overhead to patch and upgrade on premises infrastructure, managing against complex compatibility metrics per se across various hardware and software components. How to eliminate the time spent on infrastructure lifecycle management and eliminate maintenance downtime, right? So, in essence, how to accelerate the delivery of IT services and improve business continuity, right? That's a challenge and opportunity as well. Then there is a developer challenge, right? uh, how to use different APIs and tools to build applications or apps for the cloud and an on-premises environment, and then need to re-architect them to work in other environments as well, right? And these two challenges, indeed, they lead to business challenges as well. So, such as these IT challenges often lead to broader business challenges, I would say, such as a reduced return on investment for technology investments and hindered innovation and slowed business growth. It's basically time, right? And time, cost, complexity, and so forth. So, consequently, our customers requested a reliable, secure, high performance infrastructure along with operational efficiency tools and
Uh,
frameworks.
just jumping in
Yeah.
here, I've actually worked through this with a customer in terms of hybrid architecture, and
Mhm.
a lot of the points you're touching on here, it's a real duplication of cost and effort, and it's
Mhm.
much more of a balancing act between pros and cons and the overhead in terms of having two deployment structures, making sure that you are architecting the solution so it can be deployed in two locations. What services can have that latency and SLA, like it's going into that level, and it's quite a in-depth and complex overhead to the initial design phase of any project. And that's why when there can be a homogeneous environment, such as a
Mhm.
local zone to a region, it simplifies the workflow significant ways, and mainly in those soft metrics such as the planning and reducing the duplication of effort.
I couldn't agree more. So, yeah. So yeah, that's right, Casey. So essentially, what our customers want was some services, APIs, tools for automation, deployment pipeline, as you mentioned, in a homogeneous environment, or at least simulate a homogeneous environment, and right security controls in place, which you can provide you to the same pace of innovation as in the cloud, and then mm, same operational consistency and reliability and security. So that's essentially what our customers want, right? So with that, uh, maybe I'll talk about how it really it well maybe I'll briefly describe what exactly is a local zone, right?
What are you trying to say, man? What are you trying to say?
Yeah, I was trying to build a narrative. So I just wanted to give an example as well, but let me first explain or briefly, touch on what exactly is a local zone, right? Because talked about the customer, the context, and customer challenges, and I briefly talked about the region, what the region offers, and then you and our audience might be wondering, what that's right, but what is a local zone? Right? So that's what I was trying to get to. So from a region perspective, right? Just to give a high level overview of AWS region, so we have suppose we have 3 to 4 availability zones in a region, right? And then each availability zone is a combination of multiple data centers as well. So within these data centers, the customers can deploy their workloads. They can make use of AWS managed services, etc., to release their workloads. So local zone is an extension of that region, closer to those metro cities or large population areas or industry centers, right? So to be really able to take those cloud capabilities closer to those end users and customers on premises data centers, etc. So they do have their parent region. So for example, in this case, which I mentioned earlier, Auckland, the local zone, Sydney is the parent region. So that's an extension of the Sydney parent region. So we have parent regions, or the local zones have their parent regions. So basically, the control plane this sits in the parent regions. But the key thing to highlight is that you get the same experience as the customers are used to when deploying workloads in the region, right? Meaning, meaning same console, same APIs, like a single pane of glass management of your entire
A
workloads, right?
local's a local zone appears as a availability zone, correct?
It is. It does appear as an well. In when you are using a local zone, it doesn't come up. It doesn't appear as an availability zone on your console. It appears as a local zone there, right? So you choose a local zone and then I'll talk about how you can integrate with the region. But you can see that as an extension of your region. Yeah.
Yep.
So, so essentially, it can be used as an extension of the cloud, with customers being able to deploy at one location or multiple locations. So, if I may extend this local zone concept to outposts here, because I'm actually presenting how we push the boundary of the cloud to the edge, right? So in that context, for example, in an outpost, that's another bit that really sits in the customer data center itself, right? So from region extending to the metro cities, then extending to the data center of a telco, having the same hybrid experience using single pane of glass from the management perspective. So AWS experience and workload management perspective, that is what's about pushing the boundary of the cloud to the edge, right?
Yep.
So in essence, the key message here is that we have been hard at work extending the AWS cloud with new services and infrastructure options to bring applications closer to users and customers where data is generated, right?
Yep. So you've been talking about local zones and the benefits and everything like that, but can you talk more about the use cases of like using these edge
Yeah,
zones?
sure. Okay, let's talk a visual cue here. Yeah, a visual cue, more about a use case for an edge customer who will benefit from local zone, right? So let us say we have a customer in Houston, Texas, right, or Phoenix, Arizona, or a business has a corporate office in Denver, Colorado, right? They're already served by 4 regions in the US. However, latency of applications deployed to the region depends on physical distance between end users and the region, and the specific path traversed from end users to reach the applications in the region. Right. So typically, the latency to the closest regions is of the order of tens of milliseconds for those customers. In case of Auckland to Sydney, that would be between anywhere between 30 to 40 milliseconds. But here in this case, we are talking in the context of US, but I'm just giving an example as well. So, but now these customers benefit from the 17 local zones across major metropolitan areas of the United States. Local zones minimize the latency required to connect to the end users by bringing AWS services to the edge in metropolitan areas, which in most cases result in single-digit millisecond latency. So local zones are a logical extension of parent region, as I mentioned earlier. And while they are not physically co-located with the region, they instead lie in a different physical geography. So let me come back to the customer in Houston. Yeah. So earlier, the customer had to connect to the US East or Northern Virginia region. So now we have extended the region to the Houston, Texas metro area by building a local zone in Houston to serve this customer. So the network path travels between end users in the southern Texas area and the Houston local zone is shorter. The latency is lower and predictable. So this is essential for low latency applications. So this latency is in a single digit millisecond, right? So this is essential for low latency applications such as, as we talked about earlier, gaming and for hybrid IT deployments, including on-premises workloads, and either permanently or even during a migration, right? So does that give you a bit of a high-level view of a use case in a real customer scenario?
Yep.
Right.
Sounds good.
Yeah. So though the local zone is not co-located with a region, it is connected with multiple high-speed redundant network paths across AWS backbone to its region. In terms of, maybe I'll just briefly talk about, sorry,
Actually,
you,
that map did raise a question to me. Do we actually have any
mhm.
regions or local zones in Alaska?
That's a good question. Think
I'm just going to quickly Google this because
Googling.
I am
That's a good
very
idea.
interested.
That's a good idea. Know that there are 17 local zones across major metropolitan areas of the United States, but the regions, it's not on top of my head.
I know it doesn't look like there is. Oh, poor
Yeah.
Alaska.
Hmm.
Oh,
Yeah.
sorry
So
to derail you.
no, 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 no. But that's good. So you said there is no region
No region
in
and no
Alaska.
local zones in Alaska.
All right. Right.
To be fair, I don't think there's any in Hawaii either. So
Mm. Anyway, so coming back to this, maybe I'll just briefly touch on this as well. As I mentioned, this is been working this recently. So just across the ditch, right? In Auckland, as I mentioned earlier, there's a region, Sydney, which is a parent region. So uh, from our New Zealand customer point of view, so Sydney is the closest region, comprising a combination of three AZs. So uh, the distance between Auckland and Sydney, you know, is 2,200 kilometers. Yeah.
yep, give or take. Yeah,
Yeah, give or take, of course, of course, yeah, resulting in a round trip latency of around, as I mentioning earlier, 40 to 45 millisecond, or even I observed some 30 to 40 as well at some point. But give or take, say 40 to 45 millisecond, right? So depending on the service provider, indeed. Right? So while this latency may be suitable for general web applications, it can become significantly challenging based on factors such as packet size, bandwidth, or the chattiness of the application protocol. Yeah. Now, with the Auckland local zone, we have done initial testing. The latency was about 5 to 9 milliseconds, give or take. Again, it depends depending on the service provider, but we consistently noticed 5 to 9 millisecond. In other words, single digit millisecond latency, right? So, which is nearly 400% lower latency than the connected to the Sydney region,
give or take.
give or take. Yes. Yeah. Okay. So, how does it work? Again, coming back to your point earlier, how does it work, right? The local zones. We need to, or if you go to, or the customers go to the console, they have to enable local zones, right? And they use VPC, which is private network construct. Logically, you can have a VPC, which is a region-based construct extending to the local zone. So in that VPC, you can start deploying the workloads. I will show a diagram as well, yeah, later on. So in that VPC, you can start deploying the workloads and you run latency-sensitive applications in local zone. So how you can access that? Yeah, they can be accessed from the API endpoint and the console of the parent region. Right? So uh, again, to go back to your point earlier, how you can enable it. So to get started, you first need to enable the AWS local zone for your AWS accounts before you can deploy resources to them. And then you can do that from the new zone settings section of the EC2 console. And then once enabled, local zones look and behave similar to availability zones. So, I, to your point, I would not um, call local zone an availability zone, but they behave similar to availability zone, right?
Yep.
Meaning you can access local zone through the parent region's console and API endpoints, the way that you would access availability zones, right?
Yep.
Does
As the
it? Does
saying
it?
goes,
Mhm.
as the saying goes, the devil's in the details for that one.
Exactly. That's right. Yeah. So yeah, so as I mentioned, once the local zone is enabled, you can extend your existing VPC from the parent region to a local zone by creating a new VPC subnet assigned to the local zone. So once a VPC subnet is established for the local zone, you can simply select the subnet while creating local zone resources. Yeah. So I'd be very keen to talk about some use cases, Cassie. So we have talked about why local zone, what are the customer challenges, what are the opportunities, how local zones help mitigating some of those, and how it works broadly. But in terms of the use cases, right? Uh, so now we're talking about it based on what we work with customers globally, as well as the Australia, New Zealand region, right? So in terms of customer use cases, we have identified two main categories. One of the requirements from the workload perspective is latency based. Another one is location based, right? So under the latency based category, I've listed two more here, two broader subcategories. First, there are customers deploying workloads across multiple locations to serve low latency applications to their users. The second one is there are customers interested in using local zones in specific locations to create hybrid architectures or pursue hybrid migrations. In other words, pursuing uh, a phased approach of the migrations as well, right? So once achieved, the local zone appears as an extension of their corporate asset. And then the second one is a location based. So this category arises when regulatory requirements demand data to be kept within the same state or country. It's more compelling for telecommunications or telcos, right? Or we call CSPs as well, communication service providers, right? We often encounter mission critical workloads on our telco customers that cannot have their data moved out of the regions. So, in such cases, the local zone is an ideal fit from data residency perspective. So another aspect we have observed is enterprise migration, where customers want to test waters by moving some workloads to the local zone, potentially considering it as a disaster recovery site or fallback option to complement their existing infrastructure. So that is generic, but still very compelling for telco use cases. But if I want to talk very specific about telco or the communication service, the local zone use cases for communications service providers or telcos, there is a disaster recovery or cloud bursting use case, right? Meaning uh, you can design an N plus one to on premises for BCP, that is a business continuity plan, right? And there's a use case for N plus one disaster recovery and cloud bursting for standalone 5G core, which can be a lightweight, scalable disaster recovery design with a minimum footprint with active network, right? So one in local zone and one on your premise. Again, the devil is in the details. You're not delving into the details, but in terms of high availability and so forth. But broadly looking at it, a DR, a cloud busting use cases for standalone 5G core.
And I'm also going to say, see two acronyms here, MEC and RAN. I have never
Okay.
seen those acronyms before. What are they?
All right.
And also, what's
I'll try
vCPU?
to.
Like,
Yeah.
is that just
Okay.
vCPU missing a P, or is that something completely different?
Yeah, it's not missing a P. vCPU, yeah, it deserves to be on its own. I'll talk about that. Uh, see, MEC is multi-axis edge computing. So I've included here as a future state opportunity for multi-axis edge computing. So what it means is that it's often referred to as mobile edge computing as well. It is a network architecture. It's a type of network architecture that brings computational resources, including storage and processing power, closer to the edge of the network. So in traditional computing, data is sent to the centralized data centers for processing, but in MEG or multi-axis edge computing, these resources are deployed at the edge of the network, closer to where the data is generated and consumed. I will give an example, right? Um, I know you might be wondering, okay, what exactly is it? So what are the use cases? Data and video analytics is a good example of MEC. Yeah. Location tracking services for mobile devices, Internet of Things, that is IoT and IoT devices, augmented reality, the virtual reality, they can be classic examples or use cases for MEC. Yeah. Does it make sense, Cassie?
So essentially, trying not to saturize your or not saturate your main pipes back into your network. You're trying to keep all of that traffic local.
That's right. Traffic local and the latency is key here. For example, if you take video analytics, the millisecond latency, that would be absolutely critical, right? And yeah, you asked about VCU. Maybe I'll talk about that as well. So another use case I want to highlight here is the RAN infrastructure deployment option. RAN is mainly the radio access network, um, which is a critical component of mobile telecommunication systems such as 2G and 3G, 4G, and 5G networks, right? So it is a part of the network responsible for connecting mobile devices like smartphones and tablets to the core network infrastructure. Yeah? So you asked about CU, right? CU is a centralized unit. VCU is virtual centralized unit. So you're virtualizing it. Like, for example, there's a network and you're virtualizing a network. Likewise, the centralized unit, which is a key component of the 5G RAN that handles various control plane functions, the VCU is a virtualized deployment of it. Right? So it is typically located in a centralized data center and is responsible for managing multiple distributed units. So local zones can use local zones to deploy those virtual centralized units. Yeah. And then there is a concept called DU as well, like CU. There is a VDU, that is a virtual distributed unit. Maybe we can find another
I'm
time to talk
I'm
about
going to
that.
I'm going to assume rather than being centralized, it's distributed.
Oh, distributed is it is responsible for radio-related functions that are typically located closer to the cell site. Those RAN cell site, yeah,
Yep.
or base stations in telecommunication terminology. We call it G node Bs. So, so distributed units, they handle tasks such as digital brainstorming, encoding and decoding of signals, and other radio interface functions. And centralized unit is mainly responsible for managing multiple distributed units that are distributed closer to the cell site. Yeah, so you got these cell sites, distributed units, and then centralized it is they manage these distributed units. Does it make sense?
Yeah, so it's kind of like a hub and spoke model,
Can call it,
kind of.
yeah,
It's
kind
probably
of.
not.
I
Like,
don't. Uh,
yeah.
well,
I'm
it's a
oversimplifying it. I know I'm
yeah.
oversimplifying it, but I'm just trying
I,
to.
Yeah, I must interrupt you here. Apologies. I wouldn't really call it hub and spoke. The reason
Okay.
being, the centralized unit, it handles tasks such as connection setups, for example, user authentications, mobility management, and scheduling of resources, I wouldn't really draw synergies between hub and spoke model and this, this
Yep.
use case.
Rick
What
has
you
thrown out.
recommend?
Yeah, Rick has thrown out token ring network. It's gonna throw things at you until it sticks.
Yeah, sure. Yeah. Right. So these are the, yeah, typical use cases, right? Um,
Yep.
uh, Maybe I just wanted to, yeah, hybrid deployments as well. I briefly touched on that. Maybe in the interest of time,
Yep.
maybe you can move on. Um,
And I guess
yeah.
from here, because you're talking about the
Mhm.
use cases, like, do you have any guidance on when should you select a region or a local zone? Because obviously there's going to be key
Mm.
differences and considerations. Well, you've already mentioned some of it around latency, but is there consideration when it comes to the actual services or anything else like that?
Mm. Sure, Casey. That's a very good question, and yeah, I can give a bit of high level guidance around here, right? In terms of deciding between parent region and local zone, our guidance is mainly to opt the parent region when workloads do not require single digit latency, as you have spot on, right? And are not located in the same city or geographic region, right? So for latency sensitive workloads, for data residency concerns, and local data processing through machine learning inferences um, with quick results, local zone is more suitable choice. Again, we got to take a case by case, assess those specific use cases and delve deeper. But broadly, this is our guidance. Does it clarify your question?
Yeah, it's the old consultancy. It depends. Because at the end of the day, it like everything in the architecture and stuff like that, it does depend. It depends on use cases and also your requirements.
That's right. That's the use cases, requirements, industry, and so forth, right? Like, for example, I was mentioning earlier, RAN use cases. That is, it goes deeper than just latency. There's a lot more there to consider there, right? So, in terms of your high availability and so forth. So, yeah. But if you look at the edge use cases, MEC use cases, video analytics, so the latency would be quite is absolutely critical there. And data residency, it's not a choice, right? It's a regulatory compliance. So
Yep. Just before you go on, Sam, if the viewers, if anyone has any questions like around this or wants to actually, talk through any of their experiences, do leave a comment. We're more than happy to actually, get derailed a little bit. With that being said, Sam, over to you to continue on.
yeah, sure, Cassie. Yeah, it'd be great to have some questions we can talk through. But in the meantime, maybe I'll just briefly touch on some of the specific set of services available as well, right? Because talked about the use cases and well, actually, when you have the local zone, what's in there, right? What's available? Uh, Being an extent to the region. So I want to talk about some specific set of services available, and then I'll talk about how that integrates with the region as well. So these services include EC2s, where some specific instance types and families are available. Again, you got to take it case by case. Not every local zone is exactly similar. So we take it based on the local requirements and what the customers need and the demand. But broadly looking at EC2, some instance types of EC2, EBS, GPT volumes, all the basic VPC construct, uh, uh, the AWS Direct Connect and so forth, right?
I got one question there for you, Sam. So
Mhm.
with a direct connect being available in a local zone, if your
Mhm.
office is closer to or the data center or whatnot, closer to a local zone than it is to a region, would it be
Mhm.
cheaper and are you able to terminate that direct connect into the local zone to get into the AWS network?
Well, again, it depends on how closer it is, also, right? Uh, yeah, that's a good point. Uh, yeah, need to think a little bit deeper about that.
That's
But
on
yeah,
the networking team. I need to
that's
get
right. That's on the
need
networking
to get
team.
Rattan or some need to get Rattan in
Uh,
here and
uh, Absolutely,
make him explain it.
absolutely. Yeah, yeah, absolutely. I've made a note of that as well. And anything else on the services that you want to you want to expand on,
I
Cassie?
because we are talking about services, obviously there's a cost or pricing component to them. Is can you expect any differences in pricing?
Oh, yeah, sure, sure. I'll talk about that. From the pricing perspective, there's no separate pricing, but only change. We only charge for those services the customer would be consuming. In other words, on demand, right? So that's and then enterprise saving plans, which are constructs in region, are also available in local zones. Yeah. From the marketplace perspective, however, the customers pay the same price for Amazon machine images, that AMIs, and services purchased from AWS Marketplace as in the AWS region. From a data transfer perspective, right, when you talk about the pricing, it varies per location. But what I can say is from local zone, for example, I'll take this example as Auckland, right? From local zone in Auckland towards S3 in the region, if your workload does need to if use object storage in region, that is a S3, then the data transfer is free to and fro. The local zone can make use of the virtually infinite cloud storage based in the region by running the workload closer to the users in local zone itself. Does that does it cover your questions?
Yes, and there's one question that come in. I've
Yeah.
never run anything in a local zone other than CloudFront, obviously. Actually,
Mhm.
does CloudFront run in local zones? There must be some type of caching in there. Um,
Yeah.
but that's not the question. Is there a process for targeting specific local zones for, let's say, ECS?
Is there a process for targeting specific local zones from? Uh, well, in local zones we do support ECS, but is there a targeting specific local zones? Don't. I don't think there is any specific
So I,
process for targeting. If I
because
understand the
this
question correctly,
yeah, because
yeah, you
this would
go
be
on.
just
Sorry.
be your deployment options. So you'd select the local zone after enabling it as the
Yeah,
deployment for your task. So you'd be able to say this local zone, this local zone. If the home region has multiple local zones, that is, I want to deploy into these particular zones. So
yeah,
if that's what you're meaning, Rick, let us know that if we've answered the question or if you want to clarify a little bit more.
yeah.
So much he came over with so much like a region or more like an AZ.
Yeah, I would say it's more like an AC. It's similar to AC, meaning the VPC from a region can be extended to local zone. I'll show a diagram actually for Rick for Rick James, if I got the name correctly. So, for example, if you look at this diagram, right? So we got the parent region and you got a local zone. So the VPC is extended uh, to the local zone. So in case of ECS, deploying a ECS, there wouldn't be any different process, right, than how you would deploy within a region across multiple availability zones. However, there will be other considerations you will have to consider, such as the load balancing and ALBs, whether the ALB is available or not, and those are the in that particular local zone. Those are the areas that you need to consider. I hope that clarifies.
It's quite handy that you had a diagram ready for that one, because I find that
Yeah,
architect diagrams simplify it a lot.
sure. Yeah, I was intending to, briefly go through this as well if time permits. But yeah, maybe this is a nice segue as well. Maybe
Yep.
I'll just quickly talk through, given we got 7 minutes or a couple of minutes, I would say. So, as I was briefly touched on, the VPS can be extended from the parent region into the local zone by creating a new subnet and assigning it to the local zone, right? So when a subnet in the local zone is created, customer VPC is extended to that local zone, and their VPC will treat the subnet as any other subnet in AZs, right? Or availability zones. So relevant gateways and route tables will be automatically adjusted as well. Right? And then AWS local zones have their own connection to the internet. And select locations also support AWS Direct Connect, as we talked about earlier, Casey. So resources created in the local zone can serve local end users or on-premises installations with very low latency applications as well. So that is a flexibility it offers for the hybrid deployments or hybrid migrations, right? So because local zones are connected to the parent region with multiple redundant, secure, high-speed links, customers can consume any regional service seamlessly, such as Amazon S3 and RDS. You may have noticed previously when I presented the services, the Amazon S3 did not feature in that. Maybe if you want, I can talk about it, but let me talk through this diagram and complete it, right? Uh, the management console as well, I briefly talk about, for local zones is also accessed through the parent region, right? So, and all the logging and other metadata goes back to the region for the customers to view in services such as, CloudTrail and CloudWatch. Yeah. So that's bit of a high level view of the architecture. Again, you could delve deep into specific services and so forth, but yeah, that's a high level view.
Sam, we need to wrap up
Mhm.
shortly. So if you can, just go through any final statements that you want to go through, and as well, if you're watching this, if you have any questions that you want to clarify, and now is the time for it. There we
Sure.
go.
Yep.
Summary.
Thanks, Casey. Maybe I'll just summarize it, right? Essentially, the customers need cloud services closer to end users or source of data, right? To solve for use cases that require low latency, low data processing, or data residencies. I'm actually uh, including the machine learning inferences here when I mentioned about low data processing. So developers are managing these workloads on premises or on customer-owned data centers, which increases complexity and operational overhead and cost. So customer want the same seamless developer experience to manage workloads for these use cases. So AWS local zones, the place compute storage and connectivity closer to the end users are source of the data and provides customers a fully managed AWS infrastructure to manage these outcomes. So customers can deliver the end customer experience they want and also simplify their IT operations and reduce costs. Broadly, that is the core, the essence of the local zones, why we are offering local zones. And The use cases point of view, we have touched on that earlier as the low latency, the location based, and the latency based use cases. That's yeah. Thank you very much, Casey, for this opportunity. I'll hand over to you.
Awesome. Thank you for your time, Sam, and also sharing expertise on the subject. And also thank you for all of our viewers that joined us from begin to end, and also that ask questions, especially Rick James. Thank you very much. With that, I will wish everyone a happy weekend and good evening, good afternoon, and good morning, depending on when you're watching this or rewatching this. And with that, I will say Masi Wa. Goodbye and enjoy your
So,
weekend.
goodbye. Thank you very much. Thanks, everyone.